In this video, we're going to look at some examples using what are called the laws of logarithms, or sometimes called properties of logarithms. And there are three main properties that we're talking about. The first one says that when you're adding logarithms, so for example, if you have log of x plus log of y, that would equal the log of x times y. The second property says if you are subtracting logarithms, so for instance, we have log of x minus log of y, that is going to equal the log of x divided by y. And then the third law or property has to do with multiplying a logarithm by a constant. So here we have c times the log of x, and that is equal to the log of x to the c power. So you can actually move that constant to an exponent. Okay, so these properties or laws are used to expand or condense logarithms. So let's look at some examples. We're going to start evaluating expressions, or we're going to use these properties to evaluate a logarithm. And remember, you want to be able to do this without a calculator. Okay, so in our first example, we have log base 6 of 8 plus log base 6 of 27. So we can condense that into a single logarithm, and it would be log base 6 of 8 times 27, which equals 216. All right, then we can evaluate this logarithm by thinking 6 to what power equals 216? Well, you might start by thinking, okay, well, 6 times 6 is 36, and 36 times 6 is 216. So this ends up equaling 3, because 6 to the third power equals 216. Okay, let's look at the next example. We have log of 8,000 minus log of 8. So since we're subtracting the logarithms, we can condense this into a single logarithm, and we're going to divide. 8,000 divided by 8 is going to equal 1,000. All right, then we can evaluate log of 1,000. Remember, this is base 10. So think 10 to what power equals 1,000? That is 3. 10 to the third power equals 1,000. All right, in example C, we have log base 5 of the square root of 5. So the first thing I would do here is change the square root of 5 to 5 to the 1/2 power. Then what we can do is we can move the exponent in front and multiply it times the logarithm. So this will become 1/2 times the log base 5 of 5. Now, if you remember the basic properties of logarithms, if you have log base 5 of 5, that would equal 1. So this just becomes 1/2 times 1, which equals 1/2. Okay, we can also use these properties to expand logarithms into a sum or difference. So in example A, we have log base 3 of 9 times x, 9x. So we could expand that into log base 3 of 9 plus log base 3 of x. And then we could evaluate log base 3 of 9. That would equal 2, because 3 squared equals 9. So this just becomes 2 plus log base 3 of x. next example, we have log, this is our common base 10, of x cubed y to the fourth, all squared. Now, there's a couple different ways you could approach this one. You could use your properties of exponents, and this is where you would multiply your exponents and rewrite this as log of x to the 6th, y to the 8th. And then we can expand the logarithm. Since we're multiplying, this would expand into addition. So it'd be log of x to the 6th power plus log of y to the 8th power. And then we can take the exponents and move them down in front and multiply them times the logarithm. So this will become 6 times the log of x plus 8 times the log of y. Your other option would be you could move the 2 down in front and multiply it by the logarithm initially, and then expand your logarithm. So you'd have log of x cubed plus log of y to the 4th, then move those exponents down, and then the last thing you would do is distribute the 2. You'll get the same answer in the end. Either method will get you here eventually. Okay, in example C, we have the natural log of a times the square root of b, all divided by c to the 8th power. Okay, so this is an example where we're using all three of the laws, okay? The very first thing I would do, though, is convert the square root to the 1/2 power. Okay, then we're going to break apart the expression. So remember, if you're multiplying, you're going to add the logarithms. If you're dividing, you're going to subtract. So this will become the natural log of a plus the natural log of b to the 1/2 power minus the natural log of c to the 8th power. All right, and then the last thing we can do is move the exponents down in front and multiply them by the logarithm. All right, so in the end we get natural log of a plus 1/2 times natural log of b minus 8 times the natural log of c. Okay. The third way that we can use the property is to condense logarithms into a single logarithm. Okay, so we're kind of working backwards compared to the last example. So when you're trying to condense, the first thing you want to do is look for that constant multiple in front of the logarithm and move it to an exponent. So in our first example, we have 2 times log base 3 of x. We can move that 2 to an exponent. Oops, went a little too far. And we have 1/2 times log base 3 of y. We can move that 1/2 to an exponent. And then because we're adding the logarithms, we can condense it into a single logarithm. So we'll have log base 3 of, and I always tell my students, you're condensing into a single logarithm. You should only be writing a single logarithm, okay? So it's going to be log base 3, and then just put a big set of parentheses because we're going to condense the expressions into that set of parentheses. Now, since we're adding the logarithms, we're going to multiply the expression. So we're going to multiply x squared times y to the 1/2. And then the last thing we might do is convert the fractional exponent to a radical, or a square root. Okay, so we're going to do the same thing in the next example. Start with those constant multiples, and you want to move them to exponents. So we have 1/2 times log of x plus 1. We're going to move that 1/2 to an exponent. Minus 2 times log of x minus 4. We're going to move that 2 to an exponent. Now, because we're subtracting the logarithms, we're going to divide the expressions. So, again, we're going to condense into a single logarithm. I'm actually going to use brackets since I have parentheses in my expressions. But because we're subtracting, we're going to divide the expression. So we'll have x plus 1 to the 1/2 power divided by x minus 4 squared. Okay, then we can convert that 1/2 power to a square root. And we've condensed it into a single logarithm. Okay, let's look at the last example. We have 3 times log of x. So again, we're going to move that 3 to an exponent plus 2 times log of y. So again, we're going to move that 2 to an exponent minus 2 times log of x. So we're going to move that 2 to an exponent. And actually, I want to show you on this one that a little bit different approach when you're subtracting. Remember that subtracting is the same as adding the opposite. So I could make this plus negative 2 times log of x. And then I can move this as a negative 2 to my exponent. Okay, so then when I condense my logarithms, I'm now adding all 3 logarithms. So I'm going to condense into a single logarithm. And we're going to multiply all the expressions. So x cubed times y squared times x to the negative 2 power. Okay, now there's some simplifying that we can do inside our parentheses because we have x cubed times x to the negative 2. You're multiplying powers of the same base. So that's when you add your exponents. So this will actually simplify to the log of x times y squared. Because we're going to add 3 plus negative 2. Okay, so these are the examples that I wanted to show you. We will practice this some more in class. But just make sure that you study these 3 laws because you want to make sure that you know them. So I think that was all we had. Yep. Okay. All right. Thanks for watching. Have a good night.